Hello and welcome to this video. This is a rework of a video that I've done quite a few times already. The last version of this was this back in 2020, which was looking at different flight controllers. Now, back when I first started doing this, flight controllers and the software they ran were very, very closely aligned. So things like the CC3D would only run a handful of things. Things like the APM back in the day would only run things like Ardupilot. And now it's kind of a bit of free-for-all. A piece of hardware can run lots of different things. Things like this Kakute H7 can run things like Ardupilot, it can run things like INAV, it can run things like Betaflight. So no longer is it limited by the hardware flight controller that you have, it's more about what the firmware that you put on there can do. Now, the reason that I made this video is that I had another question from somebody the other day asking about the differences and which one should I use, because there's lots of very big camps on the internet defending why Betaflight's the best option, INAV is the best option, why Ardupilot is the best option. And actually, they're good at different things. So it really depends on what you want, the kind of model that you're going to fly, the kind of flying that you want to do, and the kind of features that you're after will kind of inform which one you're going to choose. Now, a couple of quick caveats before we get too far into this. This is my opinion. Different opinions are absolutely available. This is based on my experience building lots and lots of different things with these three main flight controller softwares that I'm going to talk about. The main ones I'm going to talk about in this video are going to be INAV, Betaflight, and Ardupilot. Now, there are lots of other things out there, PX4 and lots of other different bits and pieces, but I use these three because I find they work incredibly well. I have videos for beginners to show you how to set up each of these individual flight control firmwares on whatever hardware you're using. I'll put links down below if you want to go and have a look at that and see how this stuff actually goes together. There is no one size fits all, as I've already alluded to. It's better to figure out what you want and what the software needs to do for you, and then you can figure out whether or not it's an INAV ship or a Betaflight ship or an Ardupilot ship that you're going to put together. Don't start with a definitive idea that you're going to use Betaflight and then try and do mission planning on it, because it isn't going to work. Knowing what you want to do or have an idea what you want to do will get you to the answer a lot quicker. Similarly, this is being recorded at the end of February 2023 and things are changing all the time. So just like that video that I looked at a while ago back from 2020 that's now pretty much out of date for most of the information in it, you know what, if you're watching this in 2025, we're probably going to be in the situation, go and have a look for the new video. Now, one of the dangers of asking for advice in places like forums for stuff like this is that there are lots of camps that have dearly held opinions on which one is the better of whichever software that they're looking at. The problem is with best and better, words like that are very subjective. And without knowing what you as a pilot actually need, the kind of model that you're going to build, the kind of flying style, your experience, what you're going to need to do in the future, better and best, you can't actually give a reasonable answer to, because better and best requires on that knowledge, and you as a pilot, particularly if you're new, might not actually know that. So hopefully by watching this video you'll get to the end and have a better idea. The other thing I come across a lot is people telling me that something is easier to set up than something else. Now, I've been setting up all of this firmware, these three different firmwares that I'm talking about in a moment, for many, many, many years, and at this point I can set them all up very quickly. Is one harder than the other? I would honestly say no, I don't think they are. There are the benefit that Betaflight and INAV have an interface that look very similar. So if you're familiar with one, going to the other one is easier than going to something like Mission Planner that will feel very new to you. However, just like anything that's new to you, once you get over the initial hump and figure out how it all works, you very quickly figure out the tips and tricks and you'll be fine. So just because somebody else doesn't use that system and says it's really difficult, yeah, absolutely, they may have struggled with it, but you have to put in the time to learn the system. And what we often forget as people is that when you first did your first Betaflight build, for example, it may have taken you a whole week to get it working, but once you've built 20 quads, you know what, you can kind of set the whole thing up in 15 minutes, including making the cup of tea. So let's actually look at what some of the top things are that each of these firmwares have. And again, I'm not going to get into the minutiae. This video is absolutely aimed at those of you that are relatively new for this. If you know of things, extra things that this software does, then you know what? It's probably not the video for you. This is really aimed for those people, and for those people who I get questions from a lot, where they're looking at building their first UAV, drone, wing, multicopter, whatever it is, and they are just stuck on which one do I go for. So let's start with Betaflight. Now, Betaflight has been around for quite a long time. It is the current version of what started out as MultiWii, then became Baseflight, then became CleanFlight, and then became Betaflight. Betaflight is really all about the racing. So this is very much what the racing community will use. There are other firmwares around that people will like, but the vast majority of people these days and the videos that are getting made are on Betaflight. It does provide some basic GPS functionality. So if you add a GPS, it will give you things like the latitude and longitude on your screen. It also has some basic distance, direction to home information, give you basic telemetry. It now has an improved return to home landing if you're a quadcopter, because this is all really quad stuff at the moment. There's nothing in here for things like flying wings and stuff like that. Gives you basic camera control. Lots of flight controllers these days have some kind of built-in functionality where you can do things like turn the power on and off to a camera, or you can do things like switch between one camera and a second camera that's plugged in, and that's all set up through Betaflight, usually using one of the custom user 1 or user 2 flight modes. Has a PC interface. You've seen this a million times in lots of different places. The PC interface is going to look very similar to the INAV one that we'll look at in a second. There's also a phone app. SpeedyBee do a phone app that you connect to it via Bluetooth. Lots of flight controllers have Bluetooth on now, and you can pretty much set up a flight controller at this point without the need for a PC. It's incredibly handy at the field. If you want to tweak something that you don't need to pull a computer out, you can pull out your phone, connect to it with the SpeedyBee app, and you can make the changes you want to. And then there's lots of things that it does. It supports all kinds of FPV, whether it's analog, digital, walk-snell, DJI, HDOSD, all that stuff's in there. Support for all the protocols kicking around, S-Bus, CRSF. CRSF is going to give you Crossfire, Tracer, Express LRS, all that stuff's in here. There's Lua support, so you can have a script on your radio. You can send the telemetry and information back, but also change the settings as well on the flight controller from your radio, which is also very handy if you're not using something like the SpeedyBee app. It can log, so you have black box logs that you can look at. It's really only about quads, as I've already mentioned, and it has a massive flight controller hardware support, and there's lots of options in here. You don't have to spend a lot to get a flight controller that's going to run Betaflight. At the moment, F4 is kind of the entry level, but there are F7 and also now H7 with things like that new Kakuti board from Holybro that are now starting to come out. So let's add its cousin INAV into the mix. So INAV has an awful lot of the same things. It has the same or very similar PC interface. It's slightly different because it has some additional functionality. Also widely supported on the phone app as well, and has all that kind of same support and goodness. And there's lots of cross-pollination between the Betaflight project and the INAV project. But INAV has a lot of extra things that it does. So it has simple programmable logic in here as well, things like logical switches. It provides some basic soaring, so if you want to do kind of glider stuff, it understands all about that, because it does support planes and wings, something that Betaflight doesn't do. It also gives you much better telemetry. You get an awful lot more telemetry from INAV. So for example, for things like the DJI system, the older one, if you're not using something like the WTFOS hack in your DJI goggles, the basic telemetry from Betaflight is what was developed to run on it. INAV had to dumb down the telemetry that it produces in order to work with the DJI system, because by default, the telemetry that INAV gives has a superset of what you get in Betaflight. It does allow you to do basic missions, so you can assign an autonomous set of waypoints and it will fly those. It's rather basic compared to what we're going to look at in a moment, but it does allow some kind of fun things. So you can actually program a model to fly autonomously, and you can kind of just operate the gimbal or whatever you can do. Check local laws for what you're allowed to do in your particular area. It also supports things like airspeed sensors. It's quite a basic support at the moment. It'll give you your airspeed. It also supports things like boats and rovers. So if you want to put things like INAV on a boat or a rover and have those run autonomously, then you can do that too. And in fact, I did a video all about that where I stuck INAV into a boat and we had a play. I even put FPV on it. It also has some really nice automated landing stuff. So whereas with the Betaflight stuff, the return to home landing, which used to be called GPS rescue and was terrible in my humble opinion, it's going to be much more improved by the next version that comes out. It'll actually fly the quad back to you, land it. That's been something that INAV has done for 5-6 years at this point, probably even longer than that. But it will also do automated landings for fixed wing too. It's more like a controlled crash for fixed wing, to be honest, but it will do it. And then last thing, it gives you an awful lot more GPS functionality. The GPS Plus stuff, what I mean by that is that rather than it just giving you the latitude and longitude like you get with something like Betaflight, it also then uses the GPS I would consider properly and understands things like a compass. So even in higher wind situations, the model is going to come back to you, because unfortunately the way that the direction is calculated without a compass is very susceptible to problems if you're flying in anything but a stiff breeze. The last one to talk about then is going to be Ardupilot. Now, Ardupilot used to be a little bit of an exotic one for lots of hobbyists because it ran on expensive hardware. So Ardupilot has a lot of things in common with both Betaflight and INAV and with INAV. So it has now all of the same kind of support in Betaflight for all kinds of FPV. So the digital analog is in there, things like support for CRSF, for Crossfire and Express LRS. It has great lure support, does logging better than most actually, supports quads, planes, wings, boats, rovers, has broad flight controller support. So Ardupilot now will run on flight controllers that you would normally, traditionally, historically, have run just INAV or Betaflight on. So you don't have to buy a £200, £300, £400, £500 Pixhook system to run it. You can run it on a flight controller that you've probably already got. But it does an awful lot more. So things like advanced camera control. So rather than in Betaflight, where camera control is where you can switch a camera on and off and switch between one or two cameras, and that's really just Betaflight controlling some clever circuitry on the flight controller. With advanced camera control, you can do some really smart stuff, really manage the camera. So you can turn it on and off, you can zoom, you can start, stop recording, and the cameras that are available that interface with Ardupilot can also do things like intelligent tracking of objects. You also have things like antenna tracking. Antenna tracking is absolutely part of Ardupilot. Advanced sensors, so you can have things like LiDAR, sonar, which gives you obstacle avoidance. It's all run through something called Mission Planner. Now, Mission Planner is a very different interface from the one that INAV and Betaflight uses, and I think that for some people is why they talk about it's hard to set up. However, I've shown in my last series where I popped it onto a quadcopter frame. In that instance, I did use a Pixhook, but the actual setup itself was probably only about 20 minutes. But the whole thing, explaining everything, took a couple of videos to go through, and then I did like a maiden video at the end. Mission Planner is starting to feel a little bit old. A guy called Michael Osborne has done an amazing job with it, but things like VTOL, which I'll look at in a moment on this slide, is something that at the moment is kind of hidden away in lots of settings. There's no like tab for VTOL. So there's VTOL on the slide. So if you want to do vertical takeoff and landing, Ardupilot is what you want. These two don't do it. I've seen people trying to make it work, and some of them have got away with it, but for real Ardupilot, that works. And that's because, as well as having advanced sensors, it also understands airspeed. So with those kind of advanced sensors, with proper VTOL, rather than the basic hobby grade VTOL, you can actually have the model do things based on its airspeed. So as it's decreasing its speed in the air and the wing is getting towards the speed at which it will stall, then the VTOL system can automatically take over and make sure that the model doesn't crash. That kind of stuff is just kind of built in with Ardupilot. Lots of pilots use it for surveying and for photogrammetry. You can create kind of 3D images of stuff because you can geotag. Ardupilot also supports things like RTK GPS that I'm going to do a video on soon. Also supports, as well as quads, planes and wings, boats and rovers. Also supports submarines and gliders as well. And in fact, it does a great job with gliders because it also does thermal soaring. So it will detect when it is in lift and manage that when you're flying, and kind of let you know that that's happening. And if it's flying autonomously, it'll actually allow it to find those areas of lift and take advantage of them. You can use a Pixhawk flight controller rather than the cheap flight controllers that everything else is using. They're much more expensive. They have some advantages over the other flight controllers. They have things like sensor redundancy, vibration isolation. They have things like internal heaters that make sure the IMUs don't drift because of temperature. They have things like advanced interface support. So if we go back to the slide, you can see here there are lots of things that you'll find in Ardupilot, like CAN bus. Lots of other interfaces like Ethernet as well that Ardupilot understands for larger builds. Then you have things like the advanced telemetry, and also you have helicopters. This is one of the few softwares that I know that work really well on helicopters. So rather than being a multi-rotor, it's a single rotor system. So the setup is very similar, but it means that you can fly a helicopter model autonomously. Going back to the advanced telemetry for a moment, I did a little bit about this where I showed how you can use things like telemetry radios. So as you fly the model, you can very easily set it up so you have all the flight information on some kind of tablet or PC, and you can not only monitor it, but you can actually fly it that as well. You can kind of click on the map and the UAV will fly to that position. That's why things like surveying, photogrammetry, things like mapping is really good with this system. And then finally, we have advanced automated landing. The landing in Ardupilot is a million miles away from what Betaflight and INAV can do in my experience. It will do the same for a quadcopter. In fact, we saw that in the build that I did recently. It will kind of do the same for that you can get, it does with INAV, and now Betaflight has caught up and does the same thing. But automated landing with fixed wing, which I'm going to do a video on soon, is absolutely fantastic. Ideally, if you add an airspeed sensor and you add something like a LiDAR or sonar so it can detect its height above the ground, it will come in, land and flare and be amazing. If you're using reversible props, it'll even reverse the props to rest the speed so that the last bit of the landing is managed beautifully. Ardupilot, even with all my years of flying, can still land a fixed wing model better than I can. So hopefully that gives you a bit of an idea of what some of the big things that I look for and I think about when I'm choosing between those three systems are. So when will I use Betaflight? Well, Betaflight for me is the default for when I want to use something like a 5-inch quad or less, and like a Whoop or an indoor flyer or a smaller model. Then Betaflight's what I go for. Tends to be on the models where I'm flying FPV, whichever version I particularly am interested in, and I tend to use it when I'm not that bothered about GPS features. If I'm going to use the GPS return to home, the new feature, rather than the horrible GPS rescue mode, then, that's there to try and get the model back. But I'm not that bothered about doing missions or any of the more advanced stuff. And it's great because pretty much every flight controller manufacturer that comes out at the moment is going to make sure that the flight controller that's in there is going to run with Betaflight. And at this point, the default Betaflight setup, going through and flashing and configuring the controller, has become a lot easier because a lot of the defaults straight out of the box are the right ones. In terms of choosing INAV, well, INAV I tend to put on larger quadcopters where I am going to have GPS and compass on there, or I'm going to put INAV if it's a wing or a plane, and there's lots of INAV series on the channel where I do just that. Having that GPS on the model gives me an awful lot more confidence that the thing is going to come back and work. when you're putting something like a GoPro camera on a 300-pound quad, not pounds as in weight, I'm talking about cash, then if you add, your GoPro, which is going to be another 300, you've got a lot of money flying around. In the event that something starts to misbehave, or the FPV feed gives up, or your spotter starts to wonder where it is, or lose it in the cloud, or whatever it is that you're doing, you can hit the return to home, and it has never let me down. So far, touch wood. It's also great because there is that virtual cockpit on the radio via the Lua script that you can have on modern radios that shows all the information about GPS lock position, the attitude of the craft, the battery voltage, all that stuff. So you have that ability while you're flying it if you get into trouble, so as it's flying back you can monitor it, but also when you first plug it in and wait for your GPS lock, that stuff's all happening. And finally, it's just like Betaflight to set up. There are a couple of additional steps in terms of the accelerometer calibration is a little bit more intricate, but you tend to find flight controllers that can also fly fixed wing tend to have that as standard. But it's incredibly easy to set up as well. And if you're coming to it from Betaflight, it'll feel very familiar, and the interface will kind of be one less thing that you have to be able to learn how to navigate around. The last one that we need to talk about then is Ardupilot. Where do I choose Ardupilot? Well, I don't choose Ardupilot a lot because, to be honest, all I'm using Betaflight for is just be the flight controller to fly around to give me my OSD. With INAV, I tend to just use it to give me OSD, an auto launch for the wing or plane, and also things like a solid return to home so I don't lose my action camera, and things like Ardupilot tend to go on the bigger models or things that are going to have more expensive stuff inside, such bigger quadcopters and also potentially planes and wings. And again, this is more for me when I want a super smooth flying experience. Ardupilot, I find, compared to INAV, gives a smoother flight experience when you've gone through the auto tune. Using something like the cruise or fly-by-wire A or B modes, it is incredibly stable and it feels very, very locked in. It's kind of like flying on rails, and that's great for things like filming. So if it's something that I'm going to put a camera on, Ardupilot is, in my experience, a better choice than INAV, and it's easier to get that super smooth, buttery flying that actually makes the footage look great. It's also very handy for advanced missions. So if you want to fly over a particular area and you want to be able to have missions that you can be quite sophisticated with, set up a grid and put a camera in it and control that camera. So you can do things like surveying and photogrammetry, used a lot in things like farming, commercial applications, then Ardupilot is the go-to. And again, you don't necessarily these days need really expensive Pix hook systems to do it. A lot of the professional UAV builders that I know don't use anything else but Pix hook style flight controllers. But if you have your little flight controller that you would normally run INAV and Betaflight on, there's a very good chance it'll run Ardupilot too. So you don't have to spend serious money on a flight controller in order for that to work. So hopefully that's been interesting for those of you that are looking at which one do I choose. If it's a smaller quad, I'll go with Betaflight if I'm not bothered about GPS. If it's a quadcopter, plane or wing, and I just want the basics and OSD, GPS modes I can rely on, auto launch, a GPS return to home that's going to work, I'll go with INAV. If I want something a little bit more, things like that extra mission ability, things like the ability to have that super smooth flying, then I will go for Ardupilot. So again, links down below to my beginner series for all three of those if you're interested in them. But hopefully now you've got a better idea of where I use them for, but also what those systems can really do. And if you have an idea now of which one is the one that's kind of going to suit what you're trying to do, you now know which one to go and do your research on. Best of luck for whatever it is you're about to build. And if you get stuck, pop me a question on one of the relevant YouTube videos for the question that you've got, and I'll do what I can to help. Thank you for spending your time today watching that video. You can find me in all the usual places on social media, and if you're trying to learn about a subject, then check out the playlist. All of my videos are organized into easy to follow playlists that if you're trying to learn a topic will take you from the basics right the way through to some pretty advanced stuff.